Hello everyone, welcome back to 14th session of this IoT course. Last session I have demonstrated two projects. One is air temperature control by using Raspberry Pi and DHT11 sensor. Another one is car parking system by using Raspberry Pi and ultrasound sensors. Today I will demonstrate how to build IoT application by using Cloud4Rpi services, Raspberry Pi and sensors. Agenda of the session. First I will discuss what is Cloud4Rpi, then I will show you how to create account in Cloud4Rpi, then I will show you how to install Adafruit library in your Raspberry Pi, then I will show you how to configure Cloud4Rpi account, then I will show you how to connect Raspberry Pi with Cloud4Rpi. At last I will show you visualizing the analytics. What is Cloud4Rpi? Cloud4Rpi is a cloud platform that allows you to connect and control your Raspberry Pi or maybe other devices using customizable dashboards which you can set up in minutes without creating a custom backend and front end. By using Cloud4Rpi, you can get data from different sensors, control something using relays, run a web services, etc. For the majority of IoT projects, you need to manage and monitor your device remotely. So that is why you can use Cloud4Rpi for your IoT project. Now I will tell you how to create an account in Cloud4Rpi. Guys, you can see the interface of Cloud4Rpi. Go to at top right side and click on register if you are not an existing user. If you are an existing user, click on sign in. Then you have to give your email address and you set a password and click on register. Then you will get this dashboard where you have control panel and devices. Click on device and click on new device to create a new device. Now you can rename this DHT11 like this. You can rename it in your device, whatever device you want. And guys, you can see there is a device token that is needed when you connect your Raspberry Pi with this Cloud4Rpi services. Now I will show you how to create an account in Cloud4Rpi. Go to your browser and type cloud4rpi.io, cloud4rpi.io, then enter. You will get this interface. Click on register, right, and give your email address. In my case, Himadri Nath Shaha 5458@gmail.com. Then give you password, like it should be strong. Then click on register. But point to be noted, after registering into this Cloud4Rpi, Cloud4Rpi will send one email to your account for verify email or confirm email. Just click on confirm email after registering, and then only you can receive the message, otherwise not. Guys, you can see the dashboard. Also you can see there are two tabs, one is control panels and device. By default device is clicked, so that's why you have to go to new device and click, and you can rename this part. So you can type temperature and humidity. Okay guys, you can also see the device token that is needed when you connect your Raspberry Pi with these cloud services. Okay, so that is the way we can create an account in Cloud4Rpi cloud services. It's very simple. Now I'll go to once more the presentation. So now I'll show you how to install Cloud4Rpi in Raspberry Pi. These are the commands, guys. Sudo apt install git python -pip -y. So you can just type this particular command in your Raspberry Pi terminal. So then you have to install the Cloud4Rpi. This is the command, as you can see. Now we need some sample code. After that you have to type this command in your Raspberry Pi terminal. So now this is the project, automatic air temperature optimizer using temperature sensor. What is the problem statement? Temperature control is an important part of many industrial processes. Raspberry Pi allows us to automate this process with ease. Here we use our DHT11 module to track temperature and humidity to keep track of the environment it is in. You can add a temperature controller to the Raspberry Pi which releases coolant when there is a high temperature. But in our code, just have implemented like this. We will set the alert over here, so by which you can, as soon as the temperature will increase, so they'll send the alert to your email account. This is the circuit diagram. Guys, you can see that this is the DHT11 sensor. It has 3 pins. So one is positive, that is VCC connected to 5 volt. Then the black one is the negative, it's connected to ground, and the middle one of the data pin is connected to pin number 4. Now I will discuss different components of Raspberry Pi. This is Raspberry Pi 3B Plus. I'll open the case. This is Broadcom processor. This is Wi-Fi and Bluetooth module. There are 4 USB ports for connecting your keyboard, mouse. This is Ethernet port for connecting Ethernet cable to get the internet through Ethernet. This is audio port where you can connect your headphone and microphone or speaker. This is Pi camera slot where you can connect your Pi camera. This is HDMI port through which you can connect your LCD display or monitor or TV, whatever you want. Guys, I'll show you the SD card. This is the SD card. In this SD card, you have to install the Raspberry Pi OS. After installation, guys, you can see here, you can insert it into this SD card slot. That's it. This is micro USB type B port through which you can connect this wire, and now you can connect this wire to your laptop for getting power. This is LCD display slot. You can connect small LCD over here. But this is the port through which you can connect your LCD TV or monitor, all these things. But point to be noted, this is HDMI port. If you have VGA port in your monitor or TV, you have to use one adapter to convert VGA to HDMI. Then only you can connect to this port. There are 40 GPIO pins over here. Each of the pin having different functionalities. For example, ground pin, VCC pin, or you can say these are the pins, the GPIO pins, which can be connected to your device or the sensors according to your requirement. This is the blue one, is called the printed circuit board. So already I told you this is the type B cable. The one part is connected to this Raspberry Pi, another part is connected to the laptop or your computer, whatever you want. Now I'll assemble all these components for this project. This is Raspberry Pi. Already I have discussed about that. This is DST11 sensor which has 3 pins. A positive, there is red one, will be connected to 5 volt of Raspberry Pi. The middle one, that is data pin, will be connected to GPIO pin number 4 of Raspberry Pi, and the negative, that is ground, will be connected to ground pin of Raspberry Pi. Now I will connect this sensor to this Raspberry Pi. First I will connect this pin, that is positive pin, to Raspberry. So connected. So now I'll connect the ground pin to this one. So now I'll connect the data pin to this GPIO pin number 4. Now I'll connect my micro USB type B to this Raspberry Pi and to my laptop. Guys, you can see the power is on. Tell you how to install Adafruit library, or you can say DST library, in your Raspberry Pi. Guys, already I told you. So guys, you can see the commands. You can type these commands in your Raspberry Pi to install the DST11 library, or you can say the Adafruit library. This is the code. I'll explain the code. So guys, you can see in this code it is written import Cloud4Rpi, then also importing Adafruit DST. This is the function Adafruit underscore DST.read underscore retry, that will actually read the data. So here this function needs two value, two arguments, one the sensor number, that is 11, and the pin is 4. So that is recorded in humidity variable and the temperature variable. And then guys, you can see we have added one token, so you have to copy paste this one. I'll show you guys. After that, you can see that sending interval is 30 seconds. This is the type. The DHT11 temperature is a numeric, and the humidity is also numeric, and it also senses the CPU temperature. That's why it is also numeric. So guys, already I told you, subscribe and publisher protocol, MQTT. Just guys, you can see this is the device publish, sending the data. Okay, so that is the main thing. Guys, you can see this, we are actually using the different intervals also. Adds 1 second delay to ensure device variable are created, because I have used time.sleep1. So guys, you can see device.publish data, device.publish underscore diagnostic. If data underscore time are less than equals to 0, that is the most important thing. Okay, data sending interval. Okay, similar for other one also. And this is the functions, that is the Cloud4Rpi.connect to connect the cloud, and you have to pass the device token. That is most important to identify the channel. This is more or less all about the code. So now I'll show you how you can add analytics. Just go to control panel, click new control panel, then get a proper name for the control panel, then click on add widget. You will get this one. There are different widgets. You can click whether you want to visualize data in form of chart, number, text, gauge, whatever you want. We have wide range of options. After clicking that, select the variable from this one. You have to choose the variable. So in my case, it's DHT11 temperature, humidity, and CPU temperature. Select this variable. You will get this one. This is the visualization panel. Okay guys, so now I'll go to Cloud4Rpi once more, copy the token, and then I'll go to, now I'll open advanced IP scanner, click on scan. As you have seen, I have connected Raspberry Pi and DHT11 sensor to my laptop. Okay, so as you can see, this is 192.168.0.12. That is blue, that is active. So I'll copy this IP. Minimize. Click on remote desktop. Then copy. Then connect. Yes. Give username is pi and password is /3. This is my Raspberry Pi interface, guys. And this is my port. Already I have explained this one. copy it. Just copy this one, guys. So I'll stop the process, the previous one, and then click on run. As soon as you click on run, guys, you can see it's connected. So now once more I'll go to Cloud4Rpi. I'll minimize this one and go to Cloud4Rpi. As you can see, DST11 temperature is 28 degree, and then humidity is 31, and the CPU temperature is this. Okay, that means this cloud is receiving data from your Raspberry Pi. Okay, guys. So now we'll go to control panel and then click on new control panel and name it, let's say DST11. Okay, guys, and then click on add widget. As soon as click on add widget, you will get this screen. There are many options to select. So let's start with gauge. So now you can choose variables from here. This is temperature, then this is minimum and the maximum value is okay, so you can change it also. Click on add widget. As you can see, this is the gauge. So now I'll click once more to add widget. Once more I'll select gauge and choose DS11 humidity. You can also change the maximum and minimum range. Click on add widget. As you can see, this is the gauge for humidity. I'll click once more for CPU temperature, guys. And then click on that, add widget. So I guess I wrongly selected this one, so that's why I'll remove this one. I'll select once more, add widget, select gauge, and then choose variable as CPU temperature. You can also change the maximum and minimum range, and then click on add widget. As soon as click on add widget, you will get the CPU temperature panel or gauge, whatever you can say. Or if you want another type of visualizations, click on add widget once more. Let's say I want a line chart, so click on line chart, select variable. Let's say I am taking DST11 temperature, so then click on add widget. So as soon as click on add widget, you get this one. Okay, this is the line chart. Okay, so this is the way you can also delete from here. So you just click on delete. Okay, so this is the thing how you can visualize the data. Now what form you want to visualize the data, that is most important thing. It's kind of an analytics. So then if you set alert, already I told you, I'll set alert from here. Choose variable, let's say it's temperature. So if it is 20 greater than 20, then give one message, split coolant. soon as you write this one, then after that just click on add alert. This will be added over here. So you can set more than one alerts, not a problem. You can also set alert for humidity and many more. So that is the thing. I'll show you the alert from my email account. As you can see, I have received one email that is from the Cloud4Rpi alert. So as you can see, the message is written the spray coolant, because current temperature is 28 degree. Now I will demonstrate another project, that is anti-collision system using ultrasound sensor. Problem statement. We can monitor the position of an object remotely. If the object is too close to an obstacle, we can change its direction. Such module can be inserted in drones for remote surveillance. In this project, we connect the ultrasound module to the Cloud4Rpi cloud. You can control the movement of your object through the cloud by adding motors to it. This is the circuit diagram. As you can see from the presentation, this is ultrasound sensor and this is the Raspberry Pi. I have connected ultrasound sensor to this Raspberry Pi. In ultrasound sensor, there are 4 pins. Number 1 is VCC, number 2 is trigger, number 3 is echo, and number 4 is ground. So ground is connected to ground pin of Raspberry Pi, and VCC is connected to the 5 volt of Raspberry Pi. Trigger pin is connected to GPIO pin number 21, and echo pin is connected to GPIO pin number 20. Already I told you the purpose of trigger pin and the echo pin. Trigger pin is used to generate the pulse, and echo pin will receive the pulse. Then we calculate the duration, that is difference between receiving time minus start time, and then this duration is converted to equivalent distance. Now I will discuss different components of Raspberry Pi. This is Raspberry Pi 3B plus. I'll open the case. This is Broadcom processor. This is Wi-Fi and Bluetooth module. There are 4 USB ports for connecting your keyboard, mouse. This is Ethernet port for connecting Ethernet cable to get the internet through Ethernet. This is audio port where you can connect your headphone and microphone or speaker. This is Pi camera slot where you can connect your Pi camera. This is HDMI port through which you can connect your LCD display or monitor or TV, whatever you want. Guys, I'll show you the SD card. This is the SD card. In this SD card, you have to install the Raspberry Pi OS. After installation, guys, you can see here you can insert it into this SD card slot. That's it. This is micro USB type B port through which you can connect this wire, and now you can connect this wire to your laptop for getting power. This is LCD display slot. You can connect small LCD over here. But this is the port through which you can connect your LCD TV or monitor, all these things. But point to be noted, this is HDMI port. If you have VGA port in your monitor or TV, you have to use one adapter to convert VGA to HDMI. Then only you can connect to this port. There are 40 GPIO pins over here. Each of the pin having different functionalities. For example, ground pin, VCC pin, or you can say these are the pins, the GPIO pins, which can be connected to your device or the sensors according to your requirement. This is the blue one, is called the printed circuit board. So already I told you this is the type B cable. The one part is connected to this Raspberry Pi, another part is connected to the laptop or your computer, whatever you want. Now I will assemble the hardware for this project. This is Raspberry Pi, already I told you, which has 40 GPIO pins. This is ultrasound sensor, already I told you there are 4 pins. One is called VCC, another one is ground, another one is trigger, another one is echo. So now I will connect this ultrasound sensor to this Raspberry Pi. So first I will connect VCC to 5 volt. Now I will connect trigger pin to pin number 18. Then I will connect ground pin to ground port. Then I will connect echo pin to pin number 24 for this project. So I'll repeat once more. I have connected VCC in 5 volt port, ground in ground port, and trigger in port number 18, GPIO port number 18, and echo in port number 24. That's it. Now I will connect micro USB type B cable to this Raspberry Pi and to my laptop. Guys, you can see it is now on. So now I will show you how to add a new device in Cloud4Rpi. Already we have created the account. Click on device, then click on new device, then give a name of this device. You can give ultrasound or whatever you want. Guys, this is the device token. You have to copy it and paste it in your code when you connect this Cloud4Rpi to this Raspberry Pi. So now the code, guys, you can see there are a lot of imports like Cloud4Rpi, then rpi.gpio as GPIO, then time, sleep, and many more. Just see. So already I have discussed this thing, that the purpose of trigger and echo. So GPIO underscore trigger is 21. Already I have shown you, because trigger is connected to GPIO pin number 21 and echo is connected to GPIO pin number 20. So GPIO dot set mode, already I told you earlier, GPIO dot BCM. So now then you have to set GPIO setup trigger pin as output pin and the echo pin as input pin. Because trigger will generate the pulse and echo will receive the pulse. Then trigger pin set to true and then false, and then you have to receive the pulse. Because guys, you can see the start time dot time function and stop time dot time function. Okay, so we calculate the when the echo pin input is 0, start time equals to start time dot time, and when the echo pin is equal to 1, then we calculate the stop time, and then calculate the elapsed time, stop time minus start time. Then we converted this duration into corresponding distance by a standard formula. So guys, this is the device token we have added over here from the Cloud4Rpi. This is the data sending interval. So distance should be a numeric type. So this is the device equal to Cloud4Rpi connect. So that needs a device token. And so device dot declare is the variables, and this is the diagnostic. Diag means is basically over here also there is a sending diagnostic interval, right? So this is the this one is 60 second. Device dot declare, diag means the diagnostics. Then you configure the device dot publish, and guys, you can see, so already I told you the publish subscribe protocol, that is MQTT. So the device dot publish data means publishing data, and then after that device dot publish diag, so also mentioning the sending interval also. I guess this is all about the code. Now I will show you how you can do the analytics in Cloud4Rpi. Click on control panel, then click on add new control panel, then give a name, let's say distance, and click on add widget. As soon as click on add widget, you will receive this interface, and you select your widget, whether it's chart, number, text, gauge, whatever, and then you select the variable. In this case is distance. Click on distance, and after that you will get this one because you have selected the chart. So you will get this graph, or you can say the visualization like this. So click on edit and set alert. So now I will show you the actual thing. First I'll go to Cloud4Rpi. Go to device, then add device. You can type ultrasound. This is the device token. You have to copy paste it in your code. Copy it from here and paste it in your code. So I have connected my device. I'll copy it first. Now I'll open Advanced IP Scanner. Click on Scan. As you have seen, I have connected Raspberry Pi and ultrasound sensor to my laptop. Okay, so as you can see, this is 192.168.0.12, that is blue, that is active. So I'll copy this IP. Minimize. Click on remote desktop. Then copy. And then connect. Yes. Give username is Pi and password is Raspberry. This is my Raspberry Pi interface, guys. And now I'll paste it over here, guys. Okay guys, it's over. Let's stop it now and then I'll run it. Click on run button. Connected, as you can see. Then I'll go to once more. Okay, this is green. As you can see, this is in the distance but not yet. This is the temperature. Okay, received. As you can see, the distance value 0.05 centimeter. So now object is close to this. So already I have set the time interval 30 seconds. Please wait to change. Now I'll go to control panel, then add new control panel, give a name, distance, then click on add widget, select the widget, maybe gauge, select variable distance. So maximum distance is 100. I am to change it to 2000 centimeter, 2000 guys. Then add widget. So guys, you can see the distance. So the distance showing 6.88 because the object, this card, is close to sensor. Okay guys, you can add any other things also. Now click on alert and choose the variable, that is distance, and if it is crosses 10 centimeter, then you can say save and add. So that means if it is more than 10 centimeter, then they will give an alert to your email. Refresh once more. Yes, this is the save. That means it is greater than 10 centimeter. That means this is the value is 67.143476009369 centimeter. It is out of range. Okay guys, so that is the alert you are receiving. So now I'll show you that you can also download the Excel file. Go to device once more. Yes, you can download the your Excel file, that is whatever distance you are receiving from here. Similar for temperature, humidity also. Just download the Excel file. Guys, wait. Open this file. As you can see, this is the distance values. Now you can take this particular this Excel file, and you can do the analysis. So you can apply machine learning algorithm on that. So you can also directly take data or this file from the cloud by using some API. Okay, so you can also get a new token as an option. This is the more or less about the project. Thank you.